Question number 2 on the study guide asks us to use a graphing calculator to find the zeros, the min, and the relative maximum of this cubic function. So first thing we want to do is graph the function. So go to y equals, clear out anything you might have in there, and type in your function. X cubed plus 2x squared minus 7x minus 2. Usually you want to go to zoom number 6. If you don't have a very good graph, it's going to give you the -10 to +10 in both the x and the y. It looks like we can see pretty much all of our important points. We can't see this relative maximum here. If you want to see it, you can go to window and change your y max so that you can see it, but you don't have to. Anything you search for has to be in your domain, has to be in your x's, but does not necessarily need to be in your y. So we're okay. We can see all 3 zeros here. We can see the relative minimum. If I want to see that max, I could maybe change my y max window to 20, and that should capture it. And now we can see that relative maximum as well. So first thing we're going to look for is zeros, the zeros of the graph. Zeros are x-intercepts, so we're looking for those 3 values where it crosses the x-axis. To do that, we go to calculate, which is right up here. Second trace, go to number 2, which is 0. And then you need to give it 2 x values to look between. So this x-intercept is definitely between -1, -2, -3. It's between -3 and -4. You can enter anything to the left of this value. You could enter -4, -5, -6, -10. Not -11 though, because it's not on my graph. So anything to the left of that value that is on the graph is fine. I'm going to enter -5. Push enter. Now you need to enter an x value that's to the right of this x-intercept. -1 or -2 or -3. Any of those would be good choices. When it says guess, as long as there's only one x-intercept between the 2 values you entered, you don't need to worry about guess. Just push enter again, and it gives us our first 0. So our first 0 is -3.732. And then do those same steps, but give it different bounds. So second trace, number 2 for 0. If I'm looking for the one in the middle here, -2 is to the left, and +1 is to the right. So -2 for my left bound, +1 for my right bound. Guess I don't need to worry about. -0.268. And the third 0 is right here. Calculate the 0. It's between 1 and 3. Looks like it might be between 2 and 3, but definitely between 1 and 3. 1 for my left bound, 3 for my right bound. Guess, I'm just pushing enter again. Looks like it's exactly 2. The relative minimum is this point right here. It is not the absolute minimum because there's some points lower, but it is the lowest point in its general area. If I go left or right of that point, it goes up on both sides. So we're looking for that value for the relative minimum. We go to calculate, we go to minimum, which is number 3. And again, you just need to give it any x value to the left of that point and any x value to the right of that point. So it looks like it's at around 1. So if I enter 0 for my left bound, 3 or 4 for my right bound, that should do it. 0 for my left bound, 4 for my right bound. Guess, again, there's no other minimums in that range from 0 to 4 other than this point I'm looking for. I can just push enter again, and it found this value. My relative minimum. You can either list it as an ordered pair, 1, -6, or really we're looking for the value, which is -6. And then do the same thing with maximum. Second trace, number 4 for maximum. I'm looking for this point, which looks like it's around 2 or 3, -2 or -3, something to the left. -6 is definitely to the left, and 0 is definitely to the right of that point I'm looking for. So left bound, I'm going -6. Right bound, I went 0. And again, I at least need the y value. You could write it as an ordered pair.